now that we have composed our track and we have everything set up there, I want to talk about mixing and finally mastering your track so you can export it and it will sound great. So I have to tell you something first, and that is that while composing music, I often have the mix in mind. So I don't go into composition and then not even think about the mix. Not when I'm the producer, when I'm making the music. It's different if I compose music for an orchestra or something, but if I'm composing music for on my own computer, then I always have the mix in mind while composing. So first things first, like, mixing shouldn't be something you do just because it's kind of a part of the process or something. It should be done because you want to fix things. You want things to sound as good as you can after you have orchestrated and composed your music. So you always want to fix things before you go into the mixing process, kinda, because the better you have of a foundation of your track, then the better the mix will be, and finally the master. So having that in mind, we can move forward, and I thought I'd show you first some, before we actually go into mixing the track that we composed, I want to show you the fundamental tools and the plugins that you will use mostly as a music producer. You don't have to use very advanced stuff because, as I said before, it's mostly in the orchestration and in the composition. So we will just use basic tools, and today I'll use simple tools that come with Cubase. I want to show you some different ones with reverbs though, so I can show you the potential and the difference between different reverbs. So let's just load up some piano patch, and we can start playing around a bit with some. We can start with EQ. So if I play something here, let's see how this sounds. I mean, it already sounds very nice, so there's not much you have to do to mix this, but let's play around a bit with this. Increase the volume a bit so I can hear. And if we load up an EQ, you can check out what's inside the EQ. So let's check this curve EQ right here. And I think this is for free even. Actually no, let's do another one. Let's see what we have here. Studio EQ maybe? Alright, let's try this one. And as I explained in the text in the course, you have different parameters, right, for the EQ. And EQ is basically equalizer. So you're trying to sculpt the sound in the frequency spectrum with a certain volume level. So if you just have an EQ on and nothing's happening here, then nothing is changing in the frequency spectrum. So if I still play, nothing's happened. But if I start adding on something here, let's say this one here, and this one is at 5,000 hertz, we can change it around. Let's see what happens if we do 2,000 hertz and increase the decibel level a bit. So you see the sound is starting to change, and that's because the frequencies around 2000 are now being boosted by 12 decibels at this peak and with a fall off here. So all of these frequencies here, all of this onto here, are being boosted now. And this Q factor here will change how narrow or how wide it is. So if it's really wide, then a lot of frequencies will be affected by this. If it's very narrow, then only this the frequency that we chooses here will be affected the most. So yeah, I can even pull in this, and if I do it down, then the frequencies around 2000 will be decreased. So let's see how that sounds. You hear something's changing, something's disappearing here. So the frequencies here from the piano are disappearing. And this tool is very, very important because you change the overall frequency content of your track, of your audio. And as I said in the course, you want to fill up the space, the frequency space, in a full and rich way. And if you start like removing some stuff here, then you would have more space here for other instruments to fill up that space. And the same goes for any other place. Like, let's say we don't want the, let's do a bassy sound. Like that. If we start removing down here, let's remove something like that. We'll go through the different types here of EQ, but and we do something like that. Let's do a cut actually. And do it a bit more like this. And we start removing everything under here, like 100 Hertz, maybe around 272 Hertz. It will start going down. You'll see what this sounds like. You see? So we have removed that frequency range, and we can now fill that up with other sounds like maybe double bass or something. But you don't want to mess around too much with this unless you're absolutely sure you know what you want, because most of the sounds that are recorded, the samples, they're beautiful on their own, and if you orchestrate them nicely to fit each other, then there's not much need for all these mixing tools. But it's good to know that you have them here, and if you ever want to maybe remove some stuff here to clean up some things, or maybe boost a little bit of let's boost a bit up here, maybe you want some more highs, then you can do that, and it's very, very, very useful with equalizers. So let's use a shelf here. So the shelves are basically wherever you put this, let's remove all the others. Wherever you put this, the shelf will basically go up like this, and then you have different types of shelves with different angles here. And it's different from a cut, where a cut will basically remove everything. We'll cut it out, like completely remove it from with a certain curve here. So, and the Q factor decides how sharp that curve is. And this is this plugin that comes with Cubase doesn't have that many presets. So I mean what's it called, parameters. So in many other plugins you can have a very sharp curve here, like it cuts wherever I put this frequency, but this one has a pretty long tail. So even if I cut at 3000, there will still be some 5000 and stuff. So that's good to keep in mind when you're buying new plugins. And then you had the shelf, so you could do the same thing here, like you can do like that. You can play around with this, and you can see where you're removing or adding sound. Then you had the cut, the peak. So the peak is basically, or it's called a bell sometimes in some plugins, is just one point where you have a different Q factor, frequency, and gain. So that's it with EQs. If we add on instead, let's check out maybe, let's do the dynamics here. Let's do a compressor. So what a compressor does is let's remove this. So if I just play this randomly like that and add on the compressor, you can hear what happens. It kind of pushes everything down and up, so the low audio levels are going up and the high audio levels are going down. So you're compressing it, you're compressing the audio signal, and you do that to get a more even sound, to get a more kind of more what should I say, full sound. You're reducing the dynamic range in a certain way, and the different parameters here are threshold, so you decide when you start doing it, when you start compressing, like at which decibel level, and then the ratio is how much is being compressed, so like how hard it's compressing. And if we have 1, nothing's compressing, no matter where the threshold is. If you have 2, that means that every audio signal that comes up over this threshold is being compressed by 2. So if let's say 4 decibels goes above this, 4 decibels here, so it would actually compress into 2 decibels only. And if we take a listen to that, you can hear how it's being compressed down up here. And if I do a lot, you'll hear how very compressed sound. If I, you can see. So compressors are kind of useful, like are very useful, if you know where to use them. So let's say you want to have a close sound and a more even sound. Then you can try adding on a compressor and start with 1 ratio and then go down a bit until you find a good compressing sort of effect to it. And you can add compressors on pianos and percussion. And something that's really nice is to add a compressor on a vocal. So the vocals you can hear the breath going up and you hear the highs going down. So everything sounds very, very even and nice. So that's it. I mean, then you have the attack, the hold, release. And the attack is basically how fast it starts compressing. So if we pull this up a lot, then it will take longer time for it to compress. If I do 1, it'll compress directly when it hits over there. And the hold is basically, actually I don't know what hold is here, but release is something, attack and release. Release is something that keeps the sound, the sound that goes above this threshold, it keeps it compressed for this amount of time. So if we have a very short release, that means that the sound will be decompressed very quickly. And if I have it like this, it will be compressed for a long time. You see, it still compresses it. And that's what you need to know about compressors for now. And then we have limiters. So limiters is a type of compressor where you're basically limiting the sound. So if I load up a compressor again and I pull this all the way up to 8, the limiter is actually a ratio of infinite. So if we have 1 here and you go up to infinite, you would limit all the sounds that go above this threshold, and no sound can come above that threshold. And that's very good for a master output. So the output of the entire program, it's very good to have a limiter on there, because for the mastering later, because there won't be any clipping then. You would completely limit the sound at a certain, let's say around 0 decibels or minus 0.3. I will explain later why you should use 0.3. So that's basically a limiter. And then you have delay. So let's check out the delay. Delay is basically something that you use for an effect, something that just adds a slap to it, to the sound. You add something that, actually I can just play something and you'll hear how it sounds. Let's do a 4th here. You see? And then you can, in this plugin specifically, you can choose how spatial it is. So if it's 1, if it's 0, it's just in the middle. And the mix is how much of the sound is coming through to the delay. So if I have 100 in a mix, then I will hear nothing of the original. And then you have the delay time here. So that's the main parameter of the delays, is how quickly you will hear the sound and in what rhythm. So some will actually have like you can see different types of rhythms here, like different types of time. So if I do just 1/4, a quarter note, it'll be every quarter note of this sync of the program's BPM. 1, 2, 3, 4, and then if I do, like if I show you here, the BPM is dum 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 bum bum. see? So, and then if you have like, let's say a 4, let's do, yeah, 40, you would have so actually, yeah, 8 would be, it's just different rhythms basically, and this just adds an effect to it. And the feedback is basically kind of how much you want the original sound to affect the plugin. If you have a very low feedback, only, let's say high mix, you would just have maybe 1 or 2 delays. Okay, 3 you had there. Oh yeah, it's exactly actually as a, if I have 2, maybe it's 2. 2, 3 hours, 3 anyways. But you should play around with these and see how they work. In soundtrack music specifically, you kind of don't use delay that much unless you really want a specific flavor to it or a specific effect going on. You basically use delay more in modern music, more modern pop music, rock music, metal, stuff like that, where you can have a small delay with a low mix and maybe some longer feedback, say a quarter, and then it kind of fills out the sound in a way. It makes it more interesting, more lush. It's just nice to have the delay. And then let's talk a bit about reverb. So let me actually plug in this one thing here. I'll just play something here so you can hear. Something like that. And let me remove my keyboard because I don't have any of USB plug ports here. I'm on my portable. And then insert my iLok here. And let's add on. So there are 2 types of reverbs. One is the convolution reverb, and the second is algorithmic reverb. So convolution reverb is basically the reverb that you use with impulse responses. So you go to a place and you record the sound there. You use a sine sweep most of the time, where you capture the entire hall in all frequencies. And then you can basically add on sound after that. Let's say this piano here, and it will be like it was in that room. So to show you how that works, I'll open up Quantum Leap Spaces, which I highly recommend that you get. It's very easy to use. And this is a convolution reverb. So if we put that on here and we go to presets, we have a ton of presets here where they have recorded these places. So let's try the, let's go to maybe concert halls, offbeat, Digital Hollywood Hall maybe. Choose 3.8. So if you start playing now, oh yeah, I can't play. Yeah, let's do this. So you can hear the hall around it. And if I reduce the dry signal, you'll only hear the hall. So convolution reverbs are very useful in a lot of ways. I mean, if you want this sort of realistic feel to your reverb, where it's very roomy and very hall-like, then convolution reverbs are very nice. And churches and stuff, yeah, you have so much here. Let's do Berlin Church maybe. And then you have different presets here. Do the same thing. And you can use smaller reverbs too, where it's just a one room. Let's say 0.8. Let's do 4 here. See how this sounds. It kind of puts it in a room in a way. And if we just even here even more. So this is convolution reverb, and you use a lot in soundtrack music, where you're putting in maybe strings and stuff and all the orchestral elements, and you make it feel like it's in the same room, in one big room. And then you have algorithmic reverbs. So algorithmic reverbs are basically digital reverbs where you don't have any of these impulse responses, but you have everything is mathematical. And one of those reverbs that I love is 2C Audio B2. It's kind of pricey and kind of complex, but you still also have all these cool presets. So if we shut quantum mix spaces off, and oh yeah, I didn't talk about the parameters. So the parameters of both are kind of the same most of the time. Algorithmic reverbs have a lot more parameters because it's mathematical, but you still have the dry signal, the wet signal, pre-delay, and input signal, and all that stuff, and filters even. So dry signal is basically the inputting signal. It's where it's the source sound basically, and the wet signal is then when it has gone through the reverb and how wet it should be, how convoluted it should be, the sound. So if I play this thing, oh, let's remove the algorithmic one. Now it's no wet. You see? And then pre-delay is basically when how long it takes for the sound to hit the walls to you. So if you have a long pre-delay, it kind of takes you closer to the object, because if you're close to an object and you hear the direct sound, it will take longer for the reverb to reach your ears. So if you have a very short, like no pre-delay at all, you're basically sounding further away because the reverb and the direct sound is coming at the same time to you. And if you delay it a bit more, to about, like, let's say 50 milliseconds, which is crazy, it'll take longer time for the sound to reach your ear, so it will sound closer. If we try that out. Let's do a more wet signal so we can hear it better. It basically sounds closer, and if we do further away, it's very subtle, but it does make a big difference actually. So if we go back to the algorithmic reverb, you have a lot of things. So all algorithmic reverbs are different, and this in particular has something called time, and that's something that most have, like the length, the tail of the reverb. And then you have the mix here. So 0 doesn't have any reverb through, and 100% is all the source sound is going through this. So the entire sound is being convoluted by this algorithmic reverb. And you have the size here. So all of these stuff is calculated through acoustic science, basically acoustic engineering, and like the range, the randoms, the diffusion, the modulation rate. You have damping here. It's kind of like an EQ. Oh, here's actual EQ. Damping is more of a real acoustical thing, where EQ is just an audio process that removes. Then attitude, some different sound flavors. But if we load up some patch here, let's say single engine, let's do a Hall. Let's do Den Large Hall Premium. They all come like with different presets. And if you choose, go back to Den Large Hall Premium. I mean, they're called that because they're trying to emulate the actual halls. So if we increase this a bit so we can hear more, you see it's trying to emulate that. And if I increase the time here, it'll take 6 seconds now. You hear the tail? Very long. If I have a very short, it'll be much shorter. You see? So you can really play around with this, and like here's crazy. And that's where you enter more sound designish. Like it's still going. You enter more sound designish area. Like if there's some cool presets here too, some special effects. Let's do maybe let's see something cool. Maybe, I don't know, Colossus. That's cool. You see, it's more like a sound designish. Yeah, here it sounds weird, but yeah, you can do tons of stuff with algorithmic reverbs, and algorithmic reverbs are mostly used in like the same thing. Like both plugin types are used in all genres, but algorithmic reverb have a more clean tail to them. It has a more clean sort of sound to it, and while convolution reverbs can have more of the muddy sound, kind of like the real sound. So if you want to have a more clean reverb, then you should try playing around a bit with algorithmic reverbs. And if you want a more sort of real, like you're actually in the place, then you can play around with the convolution reverb. So that's it about reverbs. Is there anything I've missed? Yeah, so like then you have a bunch of other stuff like saturation and flanger and phaser and all this. A tip I can give you is that Melda Production, you can go to their site, they have a free bundle. So they have tons of this cool stuff going on. Like if we try some, let's do a flanger, see what it sounds like. They have all of these are free, so yeah, it has a very flangery sound, like meow, this thing. And then you can have saturation exists in a lot of plugins too, like just automatically. So saturation adds, on its own, it adds some harmonic distortion. I think it's harmonic distortion, where it sort of adds a flavor to it. It adds more warmth, it adds more edge, it saturates the sound more, which is very nice sound. Like you have a lot of the analog sort of, the analog gear, like the compressors and the reverbs, they have more saturation to them, like tube saturation, tape saturation, and all of this that come from the actual gear itself. And a lot of plugins are trying to emulate that. Let's see what we have here. Rate default. I haven't really played around this much with this. Okay, here's the rate of the. Yeah, really weird. Let's do some random. Yeah, I mean, it's cool to use this for maybe synths and guitars to get a cool vibe to it, a cool effect. I mean, this is all self-explanatory. You just go and play around with the plugins, and these are effectual plugins, so there's not much to explain. It's just about playing around with them until you find a cool sound, and you can use them for some really cool sound designish things. In soundtrack music, you kind of don't use flanger that much. Or phaser, if we check phaser, which plays with a lot of the phasing of the sound. So yeah, I can. So it plays with the phase of the sound that comes through your left and your right stereo channels. So that's the same thing there. You have a lot of different presets here, and this is also free. All the ones I have here are free. So, and then you have tremolo. Tremolo is really good. I use that a lot for trailer music specifically, where I'm tremolo. Let me show you how this works. You probably recognize that sound. Yeah, they use that a lot in guitars, like in rock and stuff. For example, Green Day used it a lot. You have the depth, so if you have full depth here, it goes from top of the amplitude and then really goes to 0. So it will be like womp, 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 like this now. And nothing. And then you have the rate of the tremolo. Something I use this a lot in trailer music is to get the stutter effect. So, you know, the dut 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 kind of effect, or bump 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 thing. So you have like here, you have different shapes. Let's try using a rectangle here, and we do full depth, and we do a rate. I think you can sync this, right? Can't you sync here somewhere? Where don't I should see it. Rate. There should be a way to sync this sometime. Harmonic synchronization. Oh my god, I can't see it. Enable. There we go. So now we took away the rate, and now it will synchronize to the BPM of our plugin. So if we do this again, like you'll hear here, I'll do the click. You can hear that good it kind of takes it away. So if we do a faster one, you'll hear better. So that's tremolo, really useful for sound design. You cannot use it for orchestral stuff. And then you have tons of stuff here. Like you have an equalizer, compressor, distortion. It's really good. Let's just use some regular distortion here. I can try some out, see how that works. So distortion is basically, it kind of pushes up the gains and stuff. It feedbacks the sound to really distort the sound and add some more grittiness to it. Yeah, it's a very distorted sound. Yeah, it's not very good on piano, but on guitars, sure, it works fine. And on some sound design-ish stuff like Brahms and some trailer music elements, you definitely have a great use for distortion. So what more can I show you about plugins? Like, I kind of show you the basic tools now. You don't really need that much more to go into mixing, but that's basically what you need to know. And there are of course other things, but like such as stereo enhancers and stuff. Like if you use a stereo enhancer, you can remove the width, so now it's completely in the center. If I go up to 100 again, it's the normal, and then it can actually go to 200, but it makes it kind of a faux stereo image, where it plays around with the different left and right, how fast the signal comes to your ears, so it tricks your brain to make it believe that it's wider than it is. So you also have like this mid. Okay, so if I just remove this and talk a bit, you have the mid side compression, where you're kind of compressing things more in the middle and less on the sides. So you're talking about the stereo image, basically. And then you have mid-side EQ, where you can take, for example, only the. Actually, let me load up something so I can show you the frequency spectrum here. Okay, so I'm not sure how this works. This is 1, 2. I haven't really played with these. But anyway, so let's say you want this area from the very bassy area, you want that more in the middle. That's something that you kind of always want in music overall. You kind of want to push it more to the middle. Kind of exception with orchestral music, where you have the double basses to the far right, so you can have some balance. But in most music, in soundtrack music a lot, where you're making trailer music and stuff, you kind of have the bass sort of in the middle, and the same goes for rock music and pop music. And then you can use mid-side stereo imaging, where you're compressing all the basses, like everything from here down, or maybe from 100, let's say 70 actually. Here, you're taking it more to the middle, while the stuff up here is more on the sides and in the middle. So you can play around a lot with that stuff to get a different type of mix and a better mix. And then you have parallel compression. That's also something I can talk about. So parallel compression is basically when you are using. Let me show you. Actually, it's easier to show you. Actually, let's just use EZdrummer here. Love this program. Let's use verse. Put this there. So now I have this thing going. I can do something called like an FX channel track. So an FX channel track is basically it's separate track with an effect on it. And if I put a compressor on here and compress it a lot, let's do something like that. And now I can basically send on this channel. I can send some of this effect into it, and that will make it sort of add on the plugin. You can have several FX channels like reverbs and stuff, and just send it instead of having this as an insert. So if we go to, instead of inserts, we go to audio sends here. We could load up the compressor, and now we can choose how much to compress, how much to add onto this. So if we start from 0 here, you can listen to how it sounds. And this is actually something that the signal goes from here. It goes from the track here, and it goes through this, and then it's being played out here. So what's happening here is I have some of the I have most of the original signal, but I'm adding on this audio send from this. So this is basically called parallel compression, where you're taking you're not compressing all of your sound from the beginning, but you're actually adding on compressed sound. And you can do a bunch of stuff with this. Like let's say you only want to add on the compressed sound of the bass and the highs, and that's where you enter sort of a more New York compression type thing, where let's take a studio EQ. Let's remove some of the mids here. Let's do more like that, maybe. So now what's left here is I'm cutting out the middle, but this low end and the high end are left, and those are what's being compressed here in the FX channel. So now if I go back to the EZdrummer and I start feeding it with that cut out compressed sound, it'll sound more punchy and clearer. You see what happens? Okay, now I'm really clipping here. I can go to stereo out. You don't want this clipping, this red stuff. That's when you're getting distortion. Let's go to, do you remember what we did? We go into dynamics, limiter, and now it won't compress anymore, because everything that goes over the limit will be completely limited. So if we do that again, now you see nothing will be clipped. So without is a normal sound, and with is adding on the compressed highs and lows. So you can do a bunch of stuff like that with parallel compression, and you can use that for percussion, for example. That's a really cool thing to do. You can use it on, you can try it on maybe some punchy string stuff to get a cooler sound. And yeah, I mean, this is what parallel compression is anyways. Now you hear how it sounds. So there are a lot of more things I can show you, but I think for now this is good enough as an introduction to what basic EQ what EQ is, and what all the basic tools like compression and limiters and all that stuff. So let's go into mixing the track that we composed in the previous lecture, and yeah, stay tuned.